Okay, so let's start with the first problem, that is Tower of Hanoi problem. So what does that problem state? The problem state that we have few rods, that is source, middle, destination, and we have some disk on source rod, and I want to move this disk from source rod to destination rod with the help of our middle node. Okay, so my goal is to move all the disk from source rod to destination rod. Okay, so there are few rules which we have to follow. So our first rule is, at any point of time we can move only one disk. We can move only one disk from the rod. Okay, and that disk should be uppermost disk. Okay, so here I can move this disk first, then this, then this. I cannot move this largest disk first to my destination. Okay, so my first rule says that I can move only one disk at a time, and that to my uppermost disk. Okay, second rule says that the smaller disk will be placed at the top of the rod. So this is my smallest disk and it will be placed at top of the rod. Then after that my second smallest, then after that my third smallest. So my largest disk will be at the last. Okay, so these two rules which we have to follow. First rule says that we can move only one disk at a time. That too from the top of the rod. And the second rule says that our disk should be in ascending order. That means first disk should be lighter, then second, then third, then so on. Okay, so this is our goal. Let's see how we can solve it. Okay, so let's say we have only one disk. In source, and I want to move in destination. Okay, so how I can move it? I can simply move it in destination in one single step. Okay, I can move it in destination in one single step, right? So in this, only one step is required. Now when I have two disks which I want to move in destination. So how I can do that? There are two rods. Okay, so in which rod I will place my lightest disk first? So this is my lightest disk. Let's name it as 1. Okay, so in which rod I can move this disk? I can move it here also, I can move it here also. Okay, so let's hit and try. So what if I move my first disk here to destination? Okay, so this is my first way. What I can do, I can move my lightest disk to destination. Okay, and after that what I can do, I can move my second disk to middle, right? So in one step I can move my lightest disk, in second step I can move my another disk, right? So after that what I can do, I want to move my heaviest disk in the destination first, then my lightest disk. So in this step I moved my lightest disk here, so I cannot move my heaviest disk here. Okay, this is not allowed. So what I can do, I can move my disk from here to source again. I can move my lightest disk to source again, and then in next step what I can do, I can move this disk to here, destination. Okay, and when I move this disk here, what I can do in the next step, I can move my lightest disk above that. I can move my lightest disk above this one. Okay, so how many steps it takes? So this took one step to move my lightest disk here. Okay, now in the second step I moved this disk to my middle. Okay, this is my second step. In the third step I moved my lightest disk to source again, because I cannot put my heaviest disk on my lightest disk. Okay, so this is my third step. And in next step what I will do, I will move one disk from here and lightest disk from here. Okay, so it took 5 steps. How we started? We started putting our lightest disk to destination, then we moved our second disk to middle, and then we moved our lightest disk from destination to source, and then we moved our heaviest disk to destination, and then my source disk to destination. Okay, so it took 5 steps. It took 5 steps. Okay, so I hope you understood it. Okay, so we are doing nothing. We are just trying to put our source disk to destination disk in same format. Okay, so we are doing manipulations. We are moving from source to destination, destination to middle. Okay, so that we are doing by hit and trial, right? So this was my first way. What I did, I moved my lightest disk to destination first. Okay, there can be second way also. So in second way, what I can do, I can move my lightest disk to middle first. In the second way, what I can do, I can move my lightest disk to middle first. Okay, so in one step, I can move it to middle. In second step, what I can do, I can move my heaviest disk to destination. It took one step to move lightest disk here. It took second step to move heaviest disk to destination. And in the third step, what I can do, I can move my lightest disk from here to here. Okay, so we can solve this problem in 3 steps only. First way took 5 steps to move all the disks from source to destination in same way. In the second way, it took only 3 steps to move all the disks from source to destination. Okay, if I observe something with this example, what I can observe is, if I move my heaviest disk, to my destination first, if somehow I move my heaviest disk to destination first, I can reduce my steps. To move all the disks from source to destination. So in the second way, I am moving my heaviest disk to my destination first. So it took only 3 steps. Okay, so if I make a goal that I will move my heaviest disk first in my destination node. Okay, so just keep these things in mind. My goal is to move heavier disk to destination node first. Okay, and for that I need to move rest of the disk. To the middle rod. Okay, let's understand it with another example. Okay, so let's understand it with this example. So let's say we have 3 disks. It's a very good example. It will clear all your doubts. Okay, so if we have 3 disks, and I want to move all my 3 disks in same manner from source to destination, how can I do that? Let's observe carefully. My goal is to move my heavier disk first in the destination. Okay, make it a goal to move heavier disk to the destination first. Please keep in mind whatever I am saying. Please keep it in mind. I want to move my heavier disk to my destination rod first. Okay, I cannot move it directly from here to here. Why? Remember our rules. What our rule says, that I can only move my uppermost disk to another rod. So to move the heavier disk to my destination rod, I need to move my rest of the disk to the middle rod first. Okay, so my first step will be move rest of the rods to the middle. If there are 3 rods in the source, I will move 2 rods to the middle. If there are 5 rods in the source, I will move 4 rods in the middle. Okay, so I will keep only 1 rod in the source and rest rod I will move to the middle. That is my first step. Okay, how can I move these 2 rods here? That we will do using our recursive function. Okay, we will write a recursive function to move these 2 rods from here to here, from source to middle. Okay, this is my first step. What I need to do, I need to keep only 1 disk in my source rod, and rest of the disk I will move to middle. How I can do that? I will write it using recursive function. Okay, so my first step to write my recursive function to move rest of my rods to middle. Okay, that will be my first step. In the second step, what I will do, in the single step, I will move my rod from source to destination. There is only 1 disk remain in the source. So I will move my disk from source to destination. Okay, so in the first step, I will write my recursive function, right? In the second step, I will move from source to destination. And after that, what I need to do, I need to move these disks from middle to destination. Okay, so in the first step, I will keep only one disk in my source and move all the disks to middle. In the second step, I will move my one disk from source to destination. And in the third step, what I will do, I will move rest of the disk from middle to destination. Okay, so this is my third step. What I will do, I will move my n-1 disk to destination from middle. Okay, so this is my third step. And how we will move these n-1 disk to destination? How we will move this n-1 disk to destination? I will write a recursive function for this also. Okay, so let's write it. I will write a recursive function for this also. Okay, so in the first step, I will write my recursive function to move my n-1 rods to middle. In the second step, I will move my disk from source to destination. In the third step, I will move my rest of the disk which I moved from source to middle. I will move middle to destination. Okay, so I think that is clear to you. Now, why I'm doing this? Because my goal is to move the heaviest disk to the destination first. Okay, my goal is to move the heaviest disk to the destination first. Why I'm doing this? Because it will decrease my number of steps. Otherwise, my steps will increase. Okay, we can do it in a lot of ways, but my task is to move the disk from source to destination in minimum number of steps, right? We want to do minimum task. Okay, so I told you that I will write a recursive function to move this disk from source to middle. And again, I will write a recursive function to move these disks from middle to destination. Okay, so what will be the parameters inside our recursive function? Let's discuss it. Okay, so let's generalize it for n disk. We have solved for one disk, we have solved for two disks, and we have solved for three disks. Okay, now let's generalize it for n disk. So in the first step, I will move my n-1 disk to middle. Okay, in the first step, I will move my n-1 disk to middle. I told you that I will write a recursive function for that. Okay, I told you that I will write a recursive function to move these n-1 disk to middle. So let's discuss what will be the parameters inside my recursive function. Okay, so let's name it as TOH, right? Now I want to move my n-1 disk. Okay, so I will pass the arguments as n-1. I want to call a function for n-1 disk, right? Because I know that if I place my n-1 disk successfully to the middle, I can move my one disk to from source to destination in single step. Okay, so I will write my recursive function for n-1 disk. So first I will pass n-1 because I want to call my function for n-1 disk. Okay, now we have three rods named as source, middle, and destination. Okay, so we will write in same manner. What will be our source, and then middle, and then destination. Okay, these will be our parameters. So we have to pass these also in our recursive function. So we will pass source, we will pass middle, we will pass destination. Okay, so in the parameters, we will pass our source rod first. Source rod. Source rod is nothing but from where you want to move your disk. Source rod is nothing but from where you want to move your disk. Okay, then we will pass our middle rod. Middle rod is nothing but our auxiliary rod. Okay, so next we will pass our destination rod. Next we will pass our destination rod. Destination rod will be the rod in which we want to move our disk. Okay, so first will be our source rod, second will be our middle rod, and third will be our destination rod. So we will pass these three in our function call. Okay, so what is my source here? What is my source for n-1? I want to move from S. I want to move from S. So my source will be nothing but S, right? And in which rod I want to move? In which rod I want to move? I want to move in M rod. Okay, so that will be my destination rod. Okay, Okay, so my destination rod will be M, middle. So why I'm taking middle rod as my destination rod? Because I want to move from source to middle. So my middle will be destination rod in this recursive call. Okay, so what will be my helper rod here? So I want to move n-1 disk from source to middle. So destination rod will act as the middle rod here. I want to move n-1 disk from source to middle. So it will act as the middle rod. Okay, so my middle rod will be destination. Right? Don't confuse between these. Okay, so again I am repeating, my first parameter will be my source rod. Okay, my second parameter will be my middle rod. Okay, and my third parameter will be my destination rod. So I want to move my n-1 disk from source to middle. So that's why that it will act as a destination rod for these n-1 disks. Okay, so this is our first recursive call. I hope you understood it. Now, what is my second step? In my second step, what I want to do? I want to move my disk from source to destination. Okay, that I can do in single step. Okay, for that I don't need to call my recursive function, right? I can do it in single step. So if there is only one disk in my source rod, I can simply move from source to destination. Okay, that is our ultimate goal. That is our ultimate goal. I want to move my heaviest disk to the destination first. Okay, so what will be my next step? I want to move this disk from middle to destination. Okay, so I will move these n-1 disk from middle to destination. So for that, I will again write my recursive function. Okay, how can I write that? My recursive function will be TOH, and I am writing this recursive function for how many disks? n-1 disk, right? So I will pass n-1. Okay, now what I will pass? I will pass source, then middle, then destination, right? So what will be my source? So what will be my source in this case? My source will be nothing but middle. My source will be nothing but middle, right? Now, what is my destination? My destination is nothing but D. My destination is nothing but D. So I will write D here. Okay, I will write D here. So, okay, so I know my source rod, I know my destination rod. Now, what will be my helper rod? See, this will be my helper rod. Okay, so this will be my helper rod or middle rod, you can say. So my S will be middle rod. Okay, so I hope you understood this recursive call. Okay, so again I am repeating. I am writing n-1. Why? Because I want to move n-1 disk from middle to destination. And I want to write my recursive function for n-1 disk. So here we will write n-1. Now I want to move the disk from middle to destination. So middle will be act as my source and destination will be act as my destination. Okay, remaining my source rod. Okay, so my source rod will act as the middle rod. So my source rod will act as a middle rod. Okay, so these three steps we need to follow, right? Okay, so this is our third step, right? We have discussed it. So these three steps we need to follow. See, I have written it also. Now middle rod will be act like a source for n-1 disk. Okay, so understand these arguments carefully, right? We don't need to learn this, right? We don't need to by heart these. We can understand it using this example, right? We have only three steps. So we can arrange that. Okay, so let's summarize quickly. We need to move our n- disk from source to middle. Why? Because I want to move my heaviest disk to my destination first. Okay, so in first step, I will write my recursive function to move my n-1 disk to middle, right? And in the second step, what I will do, I will move my one heavier disk from source to destination. Okay, for that, we don't need to write our recursive call. We can do it in single step. Okay, and what is my third step? We have n-1 disk in our middle rod. So I want to move this n-1 disk to my destination. So to move my n-1 disk from middle to destination, I will write another recursive call. Okay, so let's understand it by writing our recursive tree. So let's draw a recursive tree quickly. Let's say I am calling my function from main. So first I will pass n, right? Now I will pass my source, I will pass my middle, I will pass my destination, right? So in our recursive function, we are doing three things. First, we are calling our recursive function for n minus 1 disk. Okay, my source is my source only. And what is my destination? My destination here is middle rod. My D is act as middle rod. Okay, so this is our first step. In second step, what we are doing? We are moving our nth disk from source to destination, right? From source to destination. Now, in the third step, what we are doing? We are again writing our recursive call for n minus 1 disk. And in the third step, what I want to do? I want to move disk from middle to destination. So middle will be our source and destination will be our destination. And now S will act as our helper rod. Okay. Okay. So I will write it for n minus 1. Middle is our source and destination is our destination. And remaining rod is our middle rod. Okay. So just take care of source and destination rod. And remaining rod is our middle rod, right? And we are moving nth disk, right? Because n minus 1 disk we move to the middle rod. Okay, so we are moving nth disk. We are moving nth disk from source to destination. From source to destination. Again, we will perform 3 tasks, right? For n minus 1 disk, we will perform 3 tasks. So first task will be, I will call my function for n minus 2 disk, right? Every time I will keep on decreasing it. Okay, so now I want to move n minus 2 rod from source. My source will remain same. Okay, and what will be our destination? In the above call, my destination was middle. In the above call, my destination was middle. So now it will interchange. So my destination will be D only. Okay, and M will act as our middle rod. Okay, you understood it? My source will remain same. In the first call, I will move from source. I will move from source, but my middle and destination will keep on changing at every call. So in every function call, we are calling 2 recursive functions. Okay, we are performing 3 steps and we are calling 2 recursive functions. So my first recursive function will always have the same source. My first recursive function will always have a same source. Let's see how. So this will be my first recursive call from source to middle, right? So in this call, what will happen? I will first call for, let's say, 3. Okay, then I will call for 2, then I will call for 1, and 1 will be my base case, right? But my source will remain same. Okay, my source will remain same, but the destinations will keep on changing. Destinations will keep on changing. How? See, to move my third disk, I need to move my 2 disk in the middle, right? I need to move my 2 disk in the middle. But to move 2 disk from the source, I need to move my lightest disk to this destination, right? So let's say we have 2 disks. So to move this disk to middle, I have to move this lightest disk to here. Okay, so my destination change from middle to D. So at every call, my middle and destination will keep on changing for my first function call. Okay, so here in the previous call, my destination was middle. So now my destination will be D and it will be M, right? Now I will move my n minus 1 disk from source to middle, right? From source to middle. Now I will again call for n minus 2 disk, right? And in the second call, in the second function call, my destination will remain same. In the second function call, my destination will remain same and my source and middle will keep on interchanging. Okay, so this will be nothing but S, M and D. Let's see why my destination is not changing. Okay, so in this example, so at the end, my destination is D only, right? I want to move all my disk to D only, right? So at the end, I will move my disk from sources and middle to destination. So what my goal is, I want to move this heaviest weight to the destination first. So for that, what I need to do, I need to move this lightest disk to my source first. Okay, so when I move this to source, then what I will do, I will move this from middle to destination and then from source to destination. Okay, so for second call, my destination will remain same, but my sources will keep on changing. Okay, so in the previous call, my source was M and my middle was S. Now I will interchange it. Okay, I will interchange it. My destination will remain same. Okay, so in my first recursive call, my source will remain same, and in the second recursive call, my destination will remain same. Okay, so let's move further. So again, I will have to do 3 steps. Now here my recursive call for n minus 3. Okay, now my source will remain same and my middle and destination will keep on interchanging. So D and M, and here I will move my n minus 2 disk from source to destination, source to destination, and again I will call my recursive function for n minus 3 disk, and in the second call my destination will remain same, but my source and middle will keep on interchanging. So my source will be M and my destination will be S. And till where it will keep on running? It will keep on running until my disk will be equals to 1. If I have one disk in my source, what I can do? I can move my disk from source to destination in single step. Okay, so that will be our base condition. I hope you understood this problem, right? So what is my goal? My goal is to move the heaviest rod first in the destination. Okay, so this is our recursive tree for Tower of Hanoi problem. So I will repeat it again. First I will call it from main. Okay, and we have to perform 3 steps. First I will move my n minus 1 disk from source to middle, and then I will move my nth disk from source to destination. Okay, and at the end I will move my n minus 1 disk from middle to destination. Okay, and after every call, at every call, in my first recursive call, my source will remain same because I want to move n, then n minus 1, then n minus 2, then n minus 3 disk from source only. Okay, and in the second recursive call, my destination will remain same. In the second recursive call, my destination will remain same, and my source and middle will keep on interchanging after every call. Okay, so this is our recursive tree. Now let's write our pseudocode. Okay, so what will be our function? Let's say void coh, and I will pass my number of disks, and I will pass my source. Let's say source as character source, character middle, character destination. Okay, and I will perform 3 steps, right? In first step, I will move my n minus 1 disk from source to middle. So from source to middle. Okay, and D will act as our helper rod. In the second step, I will move my nth disk from source to destination. And in the third step, I will again call my recursive function for moving my n minus 1 disk from middle to destination. So from middle to destination, right? And that will be our source. So these 3 steps we need to follow. Okay, and what will be our base condition? So my base condition will be, if my disk is 1, if I have only 1 disk, then what I will do? I will simply move my nth disk from source to destination, and I will return it. So this is our pseudocode for Tower of Hanoi problem. Now let's discuss the time complexity. So let's go again to my recursive tree. Okay, so at every step it is calling 2 recursive functions. Okay, so at every step it is calling 2 recursive functions, right? So total how many recursive calls will be there? Okay, so at every call we are calling 2 recursive functions. At every call we are calling 2 recursive functions till number of disk, right? N is our number of disk. So n times my 2 recursive calls will be there. So it will be nothing but 2 raised to power n. Okay, so my time complexity will be order of 2 raised to power n. So this will be our time complexity. Okay, so I hope things are clear to you. Now let's code it in Visual Studio Code. Okay, so let's take my number of disk as 3, and I will call my recursive function Tower of Hanoi. For n, I will pass my source, middle, and destination here. Now I will create my recursive function. So I will pass n and char source, char middle, char test. Okay, so what is my first step? My first step is to move n minus 1 disk to middle. Okay, so my source will remain same, my destination will be middle, and my middle will be test, right? So this is our first recursive call to move n-1 disk to middle. Now I will move disk n from source to dest, right? So now I will call my recursive function to move n-1 disk from middle to destination. So I will call it for n-1, and now I want to move from middle to dest, and source rod will act as a middle rod. So these are our 3 steps. Now what will be our base condition? So my base condition will be if n equals to 1. What I can do, I can simply move this disk from source to destination. So I will simply call this and paste this. So move this n from source to destination, and I will return it. Right, let's mark in single quote. Okay, so this is our code of Tower of Hanoi. Let's run it. See this. How many steps required? 1, 2, 3, 4, 5, 6, 7. So 7 steps are required to move my 3 disks from source to destination. Okay, let's change it to 5. Run it again. So these many steps are required to move 5 disks from source to destination. Okay, now your task is take one more variable count and print the number of steps it required to move from source to destination, right? So this is all about Tower of Hanoi problem. Okay, one more observation I made was whenever n is even, the first rod you move is from source to middle. Okay, so whenever n is even, the first rod you move from source to middle, and whenever your n is odd, you move your first rod to from source to destination. Okay, so if I summarize, if n is even, you move first rod from source to middle, and if n is odd, you move your first rod from source to destination. Okay, so if you want to do it manually, you can do it. You can try it for any values of n. Take n even, then see, take n odd, then see. Okay, so these are my observations. You can dry run it. Okay, and you can also dry run our logic with some examples. Let's say 5 disks are there. Okay, so to move 5 disks, we need to move 4 disks here. Okay, so to move 4 disks here, we need to move 3 disks here, right? So just dry run it. You will understand it better. Okay, so the more you try, the more you practice, you will be better in it. Okay, so this was all about this problem. Let's move to our next problem.